So Bohr's model is not where our understanding of the atom ends. We actually have gone further past his understanding, and we now currently refer to the electron patterns as the quantum atom. And electron orbitals, it's a little bit more complicated than Bohr's model. So you'll want to make sure you understand the differences between these models, and we're also going to talk about this Aufbau diagram, which relates to how these orbitals and the energy levels interact. So Edwin Schrödinger, if you've ever heard of Schrödinger's cat, it's that guy, right? He used mathematics to better pinpoint where the electrons existed. And he found that it was quite a bit more complicated than just these concentric rings. All right, so he found that, within those rings, there's actually varying places where the electron density is higher. All right, so he further clarified what these orbitals look like, their shapes, and how likely the electron is supposed to be there. So, within a particular energy level, there may be S, P, D, even F orbitals, right? And they look, the individual parts look like this, and then when they're all combined together, it looks like this complicated shape. All right, so you're not going to have to necessarily draw the 3D representation of this, but you are going to want to understand, how the energy of the electrons compares based on which of these orbitals we're talking about. So that's where this Aufbau diagram comes in handy. All right, so a lot of times you'll see something like this in your coursework, in practice problems, things like that. And I'll also show you a shorthand way of writing this out. But the rules for how to fill out this diagram are really, really important for you to get down. All right, so first things first, you can think of it as here's your nucleus, and here, down at this end, is going to be your valence electrons, the ones farthest away. All right, and you can even think of it in terms of Bohr's concentric circles. All right, so because there's, his energy level 1, this happens to hold 2 electrons in it. All right, and then there's energy level 2, energy level 3. It's just within those energy levels, there's a little bit more detail of what's going on. So when you are filling in electrons, right, say we're dealing with an atom that has 15 electrons. All right, those electrons are going to fill in the lowest energy levels first. All right, so the first 2 are going to go into 1s. All right, and then if there is more than just an s orbital, so like energy level 2, we have s and p orbitals, we're going to fill the s orbital first. Then this is where the rules get a little particular. All right, so when you're dealing with more than just an s orbital, you're going to fill your s's first. There's only 2 electrons that you can only put 2 electrons in each of these boxes. So the s's are easy, you just put the 2 in. But when you get to something that has more than 2, what you do is first put 1 electron in each. All right. Then, and this is why I've been doing an arrow up and an arrow down, according to the Pauli exclusion principle, the electrons that are within the same box have to have opposite spins. Right? So that's why we draw arrows in opposite directions. All right, so let's see. So far we've gotten 2 electrons and there's 8 in level 2. So we have 7 more electrons to add. So we are going to add 2 into 3s. All right, and then 3, 4, 5 into 3p. And then 6, 7. All right, so the rules for doing your orbitals: fill the lowest levels first, fill S before P, fill P before D. All right, S's are easy because there's only 1 box, so you just put the 2 electrons in there. But for P's, and if you get to the point of having D's or F's, you're going to start by putting 1 in every single box, and then you're going to double up until you've put all of your electrons in. All right, so now I've got all 15 in there, all right, and our valence electrons, the ones that we evolved in bonding, are these guys at the outermost level. Okay, so I want you to try one to see if you can correctly get the electrons in for nitrogen. All right, so nitrogen has an atomic number of 7, which means it has 7 electrons. All right, so you try and see if you can get everything right. I'll probably ask you how many you've got in the 2p, or describe how you put them into the 2p box, because you're going to get that far. So we've got 1, 2, 3, 4, 5, 6, 7. All right. Now, another thing you need to be able to recognize is the shorthand way of writing this. All right. So sometimes you might be asked for an electron configuration. You're not going to draw this whole big giant picture. There's a way to just kind of type things. All right. So what you'll do is you're going to write 1s, and then to tell me how many electrons are in 1s, you're going to do a superscript 2. All right. And then 2s is the next level that we would start filling, and there's 2 electrons in there. So you're going to do a subscript of 2. And then the next area we would fill is 2p, and we have 3 electrons there. All right, so the shorthand writing of an electron configuration for nitrogen is 1s2, 2s2, and 2p3. So what we do, if you see the term electron configuration, that is what this is referring to. All right, you'll probably want to start by drawing this, but you know, a lot of times with multiple choice and things like that, you're going to see not pictures as your options, but you're going to see shorthand writing like this. So try this again with sulfur. All right, if you look up the atomic number of sulfur on your periodic table, all right, your atomic number is equal to 16, which means there's going to be 16 electrons in your diagram. So see if you can follow along with what this should look like, and then write the electron configuration of sulfur. All right, so if I were doing this, I would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, and then writing that out as an electron configuration, it would be 1s2, 2s2, 2p6, 3s2, and 3p4. All right. The other caveat that you may run into is something where you have to figure out what the electron what atom you're dealing with. If it has this electron configuration, but this actually means it has an ion of -1. All right. So a couple of different ways you can do this. You can draw out the electron configuration and then count how many electrons you have. You could add up these numbers, and that'll tell you how many electrons you have. But I'm going to draw it out. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there's 10 electrons, but that's a charge of -1. All right, so if this were neutral, it would have 9 electrons. All right, which means the atom we're dealing with, or the ion, is the ion that has, or the element that has an atomic number of 9. All right, because remember, atomic numbers will match your electrons only when the atom is neutral. So we have to deionize it, get it back to its neutral state. And that's how you'll know this is fluorine.